People argued about this for years. They traded clips and hot takes. You hear it on Joe Rogan's podcast and everywhere else. Then China brought back real evidence because China's lunar discovery proved that the moon landing's history is true by turning talk into samples that labs could test. Independent verification beats staged footage. And he's right. China's discovery answered all moon landing questions at once. Not one by one, all at once. This is the difference between talking and testing. Independent verification beats edited footage every single time. Now let's start with the simple part. China brought lunar soil back in 2020. When scientists opened those sealed containers, they found water molecules in the dirt. Not a rumor, not a blurry pixel. Actual H2O. Water in its molecular form bound up with tiny grains and glass beads in the soil. In the same batch of samples, they also identified a brand new lunar mineral later named Chang'e Site Y. Fresh material, fresh fingerprints, measured in labs that anyone can visit. So why does water and glass beads matter so much? Think of those beads as tiny marbles made when micrometeorites hit the surface and melt dust into glass. Solar wind then bombards that surface for billions of years. Some of that hydrogen and oxygen ends up trapped inside of those beads. When you heat the bead or scan it with precise instruments, you see the signature of water. It is a simple chain. Space hits the soil records the hit, labs read the record. The mineral discovery sits right next to it as a second receipt. You take the same box of soil, you sift, image, and test the crystals inside. You match their structure and chemistry, you write it up, another lab repeats you. This is not about belief, this is about repeatable checklist that leaves a paper trail. Here is why the water result changes the debate. Anyone who doubts a video can say that it's staged, but nobody hand-waves spectroscopy. Spectroscopy is just how we read light from a sample to learn what it's made of. If multiple labs can point to the same water signature and the same kind of beads and the same returned material, the burden shifts. You aren't arguing about opinions anymore. You're arguing with the readings. Even Joe Rogan picked up on this shift. On his show, he brought on guests to talk about China's new lunar samples, the water trapped in glass beads, and the strange new mineral they identified. Rogan has admitted in the past that he doubted the moon landings, but what struck him and his audience in that conversation was how the evidence had moved beyond grainy footage into hard science. When comedians, fighters, and scientists are sitting around his table talking about spectroscopy results from Chinese soil, you can see how far the debate has traveled from where it started. Now, engineers say this all the time, and yes, Elon Musk repeats it in public. Independent verification beats staged footage. You don't need to like a country, a space agency, or a personality. Open the box, run the test. If different teams get the same number, the argument shrinks. That is what happened with these samples. The water shows up where the physics predicts it should show up, inside the glassy grains spread across the lunar soil. This is also why the result sticks. The water signal in returned samples fits what orbiters have hinted at from above. Spacecraft have seen signs of water on the surface before, but spotting a signal from orbit is one thing. Finding the H2O molecules in hand in the lab is a different tier of proof. It moves the discussion from maybe to measure it yourself. Now let's build the bundle, because the bundle is what changes minds. First, you have lab fingerprints from returned samples. Second, you have visible receipts from current missions operating on the surface and in orbit. China made the first successful landing on the far side of the moon and sent images back from a place that we never see from Earth. That operational success is its own receipt. Navigation, communication, power, thermal control, all working where nobody had worked before. When you put those two pieces together, the story tightens. Fresh soil comes home and gets tested. The data says water in beads and new mineral present. Meanwhile, landers and rovers survive lunar day-night cycles and keep sending pictures. The surface looks like the physics says that it should look. Harsh light, hard shadows, dust that clings, and landscapes shaped by impacts in time. The receipts match across methods. Add the rivalry layer and the lock clicks. Different players now collect their own evidence. American and Indian spacecrafts have spotted water signals from orbit. Chinese samples then put H2O molecules on the lab table. No single country owns the record. Rivals don't let propaganda stand. If one side fakes it, the other side exposes it. Instead, the measurements rhyme. That is how the debate changes in real life, when independent tracks point to the same answer. Now think about how this bundle works in your head. Lab fingerprints are like a signature on a check. Visible receipts are the bank's confirmation stamp. Rivalry is the auditor who shows up uninvited. Each piece is useful on its own. Together, they're heavy. If someone tries to argue against one, the other two are still there. That's why this moment feels different. It's not just a video or just a paper, it's a stack. Let's run a rapid myth check using this lens. Space is too harsh for surface grains to carry a record. Not true. Those grains are literally weathered by space. The water trapped in glass beads is a physical record of solar wind activity and impact heating. You can pick up that bead, warm it, and watch the signal appear. This is what space weathering means in plain terms. Space leaves marks that labs can read. What about the lighting tricks and no stars in photos? Cameras expose for the bright surface. Stars are faint. Short exposures wash them out. You can test this on Earth with your phone in a city at night. The moon's far-side images show some harsh contrast as near-side landings. Bright Legalith, deep black shadows. It's not a glitch, it's how cameras work in extreme light. Strange shapes prove a mystery base. Well, we've already seen how that plays out. A blurry mystery hut turned out to be a rabbit-shaped rock once the rover drove closer. Angle, distance, and shadows can fool your brain. Get closer, the illusion dies. This is why operations on the ground matter. Rovers remove the guesswork that comes from zooming in on thumbnails. The dust should behave differently if it were real. The dust is sharp and clingy because it's not rounded by wind or water like Earth sand. We've watched it coat hardware in multiple missions. We have studied its chemistry and returned samples. Again, the lab view and the camera view match. 2 receipts, same story. Now let's close the loop with the rivalry lock. The far side landing wasn't a PR stunt. It required a relay satellite, precise timing, and a lot of engineering discipline. That hardware sent back images from a place we never see. It proved the team could plan, execute, and keep machines alive in a punishing environment. That same program then returns samples that any lab can request and test. This is the opposite of a closed story. It is open, measurable, and replayable. More players means more cross-checks. Every new mission adds pictures, spectra, and rocks to the pile. If any one country tried to bend the story, the others would catch it. Instead, the records keep stacking. You can't hand-wave water signatures and beads across independent labs. You can't fake a new mineral and hide it from repeat testing. And you can't land on the far side, beam back pictures, and pretend that you didn't. So, where does this leave the debate? The loud part of the argument lives on social media. The real part lives in labs and mission logs. China's moon samples revealed water and changed the moon landing debate. Not because a press release said so, but because lab fingerprints and visible receipts lined up and rivals kept adding their own. That is how science wins internet fights. You pull the thing apart, measure it, and let anyone redo your steps. Now, if you want more breakdowns like this, simple. Test first. No drama. Stick around. We'll keep following the receipts as new missions lift off and new samples come home.